Hello guys, welcome to the class. So I'll wait for a couple of minutes for some more people to join. We already have enough people, but I am sure a lot more people had registered. So let's wait for some more people to join, and then we'll start. So while we are waiting, can I get a yes from everyone if everyone is able to hear me and see my screen? Cool. So most of you have replied. You are able to hear me. All right. So guys, this session is going to be a short one. So we are just going to discuss what exactly is MapReduce in Hadoop ecosystem. In the last session, we had discussed, the use cases of big data and how it is different from, traditional technologies. Uh, I'm sure all of you are, most of you are, new to this class. You had not attended the previous session, but I would suggest you guys to go and have a look at our YouTube channel where we have uploaded the recording for the previous session. Today, we are going to discuss what exactly is MapReduce in Hadoop ecosystem. Okay, so this slide deck is actually from the previous session itself. So we had discussed, what is big data, how can data analysis help businesses, where we, talked about some of the use cases of, Hadoop and big data technologies. Then we talked about what were the limitations of existing solutions and how Hadoop ecosystem helps solving those, problems, and what are the Hadoop core components. We also looked at the architecture of HDFS. So today we are going to talk about data analysis using MapReduce. Okay, so these are slides we had discussed in the last session. So I'm just gonna jump to what we are gonna discuss today. Yeah. So today we are gonna talk about data processing. So HDFS is a storage layer component of Hadoop ecosystem. At the analysis layer, which is data processing layer, we have different components. One of the most important and popular component is MapReduce. Of course, we have Pig and Hive also. MapReduce is where you write your custom Java or Python code to solve complex business problems. All right. So mainly it is used when your data is completely unstructured, but there is nothing that stops you from writing MapReduce jobs on structured data as well. Pig and Hive are more towards solving problems on top of structured data. So Pig is is kind of a language, high level language, which is almost like English language. It's like you load your data and then you filter your data, you join your data. So those kind of statements are there. Hive is more like SQL flavor to the data processing. It's not actually a database, but it gives a database flavor to the overall processing. All right, so you can kind of write SQL queries which internally get converted into MapReduce jobs. But the topic for today's discussion is what exactly is MapReduce, right? So let's talk about what MapReduce is. So here is a very funny picture, but it kind of explains what MapReduce is. Now think about a problem where you want to make a sub. So these are your raw materials. You have a raw sub. You have different veggies that you want to chop and put in the sub. So if you think about it, if one person is making this sub, what he'll do is he'll first chop the sub. He'll chop the first vegetable, second vegetable, third vegetable, fourth vegetable, fifth vegetable. He'll do these things in series, and then he'll simply put all the chopped vegetables into the sub, right? And then your sub is ready. But in MapReduce paradigm, what you can do is you can have 5 6 different people working on chopping part parallelly, right? So this all these things can be done in parallel, right? Once all output of these tasks is ready, someone can simply combine these all together and your final output is ready. So that is exactly how MapReduce works. Let's say you have a raw data which is huge in size. You divide the data into chunks, and there are multiple machines, multiple tasks, multiple JVMs working on these individual chunks in parallel. Okay, and they produce some intermediate output. All right, and then basically at the reduced stage you combine or aggregate all the output together to arrive at the final result. All right, so basically this is your map stage where different tasks can work individually without interacting with each other in parallel, right? So this is your distributed processing. Once the intermediate output is ready, then you can run a reducer which can aggregate all this intermediate output. So we'll look at one example of MapReduce which will make things more clear. All right, so first let's talk about the traditional approach. As I just said, the traditional approach could be, let's say you have a very big data size and you want to find all the lines that match a particular, that contain a particular keyword. Now if your size data size is, let's say, 1 terabyte, if you simply run cat your file and you do grep on that particular keyword, it will take hours to complete, right? Other approach could be, let's say you have multiple machines, or let's say on single machine also you might write a multi-threaded application which will utilize more number of cores to do the same. But now you have increased the complexity of your program, which is now multi-threaded, right? Writing a multi-threaded application obviously is a little more difficult than writing a single threaded application, right? Now think about it, you have multiple machines at your disposal. If you want to utilize all the machines, what you can do is you can divide your data in chunks and send your data to these separate machines, and then on every machine you can run your uh, a multi-threaded application which will find all the lines that contain that particular word. Now from all these machines, from all these threads, you take the output together, you basically concatenate all the lines, all the output of these different tasks, and then you arrive at your final result. So that is the traditional approach if you don't have a framework like MapReduce, right? But what happens in MapReduce? In MapReduce, what happens is the framework does most of the work for you. If you think about it, your core solution to the problem is just to do a grep on the data, right? Splitting the data, dividing it into separate chunks, and then assigning different tasks to process this data, and then again combining those results is actually something which is common to most of the problems. So you don't want to do that again and again. So that's why MapReduce framework was developed. It kind of solves all these common problems for these big data problems. So what happens is, in MapReduce world, you will just write your logic in your mapper that I want to grab this particular keyword from all the lines. All right, and in your reduce you'll say I just want to combine all the results together, and the framework then does everything else for you. You just provide the big data to the framework, it will split the data for you, it will find out where map tasks can be run, where free resources are present, then it will take that small function from you and embed that function at the map stage. All right, and that function basically is now distributed across the cluster on all the machines. So all those machines, all those tasks, all those map tasks are now running your function, which basically takes a line of input and produces the output if that line contains that particular keyword. And in your reduce function you can simply concatenate all the results. So it makes the things easier for you. I hope that makes sense, guys. Anybody has any questions? Okay, Ritesh is saying, how does the framework split the data? Okay, Ritesh, I think you did not attend the last session. So when we talked about HDFS storage part, so basically in Hadoop ecosystem, when you store data in HDFS, so you have a cluster of machines, and out of these machines you have one name node and multiple data nodes, right? So when you store data into this cluster, HDFS breaks your data into blocks. All right. So there is a configuration called block size in HDFS, and it breaks your data into different blocks based on the block size and the size of your file. So if you have a 200 MB file, it will break that file into two chunks, one of 128 MB and second of 72 MB, and then it will store these blocks on the data nodes. And these blocks can go to any data node. So in a way, your data is already distributed on your cluster. right? Now when you run MapReduce on top of it, the framework which the yarn framework which actually launches map and reduce tasks, it is aware of the fact that this particular job, this particular application wants to access this data, and this data is present on these machines, right? It can talk to the name node and it can figure out where all the blocks of that particular data are present, and then it tries to launch all those map and reduce tasks on those machines where data is present. Okay, so your data, you can say, is already split, although there is a different difference in block size and split size, but I won't get into those details because those will be too confusing for you at this moment. But you can think about it, when you are storing your data is already splitted. Okay, now your map tasks are running on those machines where your data is present, and they can simply take that particular block of data and process that. Make sense? After the map tasks are finished, the output of map tasks may need to transfer to some other node where your reduce function is running. I hope that makes sense. Thank you. Himanshu is saying, how does the data flow from map to reduce? Is there only one reducer? No, Himanshu. So there are a lot of concepts for that. I don't want to get into details of that, but I can give you a pointer. So when between map and reduce, there is something called shuffling and sorting. Okay, so that shuffling and sorting is basically to ensure that the same keys go to the same reducer, and you can run multiple reducers also. I'm not going to get into details of that in this session because that will be too confusing, but that is something you can go and read, or you can maybe attend some other session from us where we can discuss that in detail. So let's first talk about what are keys and values. I mean, there's no point talking about these things before knowing what exactly are keys and values in MapReduce paradigm. Okay, so basics of MapReduce are that your map function takes a key and a value as an input. So whatever your data is, it will be divided into, every record of your data will be divided into a key and a value. Okay, so every record, so the framework provides one record at a time to a map function. Okay, and the map function receives a key and a value as input, and it emits a list of keys and values as output. Okay, and then reduce function, so basically then the framework, what the framework does is, from this list of keys and values, which is the output of map, framework will find out all the key value pairs that have the same key, and then what it will do is it will create this data structure where for the same key it will combine all the values into a list and provide this particular record as input to the reduce function. Okay, and then your reduce function can perform its logic on top of this and finally emit this result, which is a list of k3 and v3, which is again a list of keys and values. So it will be more clear when we discuss about the example of word count. So this is the example of word count. So think about this. Let's say this is your input where you have three lines: deer, bear, river, car, river, deer, car, and bear.